Hello, everybody, and welcome to PyData Global 2024. I am excited to introduce our speaker for this session, Tony Zhao, on his talk on enhancing maternal health care. Tony, thank you so much for being here and for your time today. Audience, I encourage you to leave your thoughts in the chat. You can drop questions in there or in the Q&A section, and we will address those at the end of the session. But right now, I don't want to take any more time away from Tony. The floor is all yours.
Okay, thank you, Tamara. Hi, everyone. Thank you for the introduction again. My name is Tony Zhao, and I'm a data scientist with ID Insight. Before I begin, I just wanted to tell you a little bit about myself and the work that I do. I am based in Michigan, US, and started my career in the automotive and tech industries before joining ID Insight in July of this year to work in international development. At ID Insight, we aim to work on projects that amplify social impact by partnering with leaders in the sector to develop tailored solutions. My teammates and I primarily work with partners in low to middle income countries to help governments, foundations, and nonprofits maximize their impact on issues such as agriculture, education, health, governance, and financial inclusion. Today, I want to tell you about a project we did in South Africa where maternal deaths still happen 10 times more frequently than they do in high-income countries. To give some context, we have been working with Reach Digital Health, a South African organization that runs a service called Mom Connect, a national maternal and child health helpline. Expecting where new mothers would sign up through a clinic and get timely messages about checkups, physical changes they should expect, and ask questions to trained professionals at the help desk. In 2018, over 95% of clinics and 60% of pregnant women in South Africa were signed up. It has only grown since then, with over 320,000 monthly active users currently. All that is to say, Mom Connect has the potential to impact millions of people going through pregnancy and birth. However, Mom Connect's help desk had a problem. They only had a handful of help desk operators and quickly became overburdened with hundreds of questions each day. And this led to some users having to wait hours to get their questions answered. And so with limited human resources, we wanted to ensure that only the most urgent or tricky questions would be sent to the help desk. And whenever possible, instantly address user questions with accurate content. So to address some of these issues, we actually developed a service this year called Ask a Question, or AAQ. AAQ is an open source question answering plugin that allows the users to search over hand curated contents to ensure minimal hallucinations and also be cost effective at scale. But AAQ was designed to be a general question and answering service. However, for Mom Connect, users could be asking sensitive medical questions, and the data must be stored within South Africa due to the Protection of Personal Information Act. Furthermore, we would like to decrease costs as much as possible for Mom Connect. And then critically, we still needed a way to forward the most urgent messages to the help desk. So our solution here was to develop and deploy a custom language model for urgency detection. So together with Mom Connect and Google.org, we came up with a plan to generate a synthetic data set that can be used to train a custom model that can detect when a mother is sending an urgent maternal healthcare related message. By quickly identifying and prioritizing user inquiries, the model will be able to aid the help desk by ensuring that truly urgent messages are promptly forwarded to the appropriate healthcare professionals for immediate intervention, and non-urgent messages would still receive appropriate responses based on their nature. By the end of this talk, aside from all the technical details, I also hope that you'll understand how to better think about data curation for language models, how to think about training language models, and learn about some of the common pitfalls associated with this whole process and some of the important lessons that we learned along the way. So let's get started. Okay, so what was the data challenge that we faced? Although Mom Connect had been around since 2014, they did not start labeling user messages until earlier this year. So as a result, we only had around 4,000 labeled messages to start with. Obtaining more data quickly was challenging due to a variety of reasons, such as the sensitive nature of maternal health messages, issues related to data privacy, and just the cost to label the data. When we analyzed these 4,000 messages, we also noticed that the data was heavily skewed. So the majority of messages were classified by the help desk as not urgent. This is to be expected and actually one would hope for. However, training a model in such an imbalanced data set could inadvertently just teach it to classify every single message as not urgent. Another thing we saw was that the user messages were typically short, about 7 to 10 words, and included local slang and the use of emojis. So we wanted to capture the underlying characteristics of the messages, but also expand the data set so that we have messages related to each of the urgency rules in approximately equal proportions. This would ensure a high quality and diverse data set for fine-tuning a multi-billion parameter language model. So to get started, the first thing we did was to create synthetic personas for user messages. We did this by randomly sampling subsets of user messages from the set of 4,000 and using Gemini 1.5 Flash to create user profiles that included aspects such as the persona, which is the general characteristics, attitudes, and social identities present in the messages. The linguistic patterns, which capture the recurrent vocabulary, phrases, and grammatical structures observed in the messages. The speech patterns that convey the tone, formality, and rhythm of, of the messages from Mom Connect. General message characteristics, such as the average number of words, whether the messages are short, concise, or long and detailed. And then finally, just the demographic observed in the messages, that is identifying the demographic characteristics of the group based on the languages used in the randomly sampled set of messages. So this process resulted in a pool of 160 synthetic user personas and message characteristics from which we can draw upon to create contextualized and domain adapted messages related to maternal health care. Since we would be generating user messages targeted to specific urgent conditions, our next step was to create a list of urgency rules that expanded and improved upon existing rules. That is, we wanted to make the rules more descriptive, telegraphic, and related to individuals who are pregnant or expecting or for their newborns. And so here are some examples of the existing rules and how we transformed them to be more descriptive and tailored to our domain. This step was also done using the help of Gemini 1.5 Flash. After obtaining a pool of user personas and message characteristics and the urgency rules, we then asked Gemini 1.5 Flash to generate synthetic user messages aligned with randomly selected urgency rules. Each message was generated with a system message that detailed the user personas and the message characteristics. To ensure the accuracy and relevance of the synthetic messages, we employ Gemini 1.5 Pro to verify that each generated message accurately reflected the selected urgency rule. In other words, we first had to generate a message that was targeted toward a specific urgency rule. And then after it's generated, because the language models can hallucinate or sometimes not always get their instructions right, we also went through the extra step of using a different language model, this time Gemini 1.5 Pro, to say, hey, here is a user message. Which one of these urgency rules applies to it? And we only kept those rules that matched, or sorry, we only kept those messages that matched the selected rule, right? And then the messages that failed this verification process were excluded from the final data set. And this is how we ensured a high quality, that only high quality relevant messages were included for model training. The resulting data set consisted of approximately 13,000 messages now, 12,000 we used for training, and 1,000 were reserved for validation during the training process. So you can see from the plot here, and the y-axis is log, that the distribution of the urgent rules are much more uniform. So the first one all the way on the left-hand side is not urgent, right? And then the rest are all the actually urgent rules. So there's about 34 urgent rules and one not urgent rule for a total of 35. And so from this synthetic data curation process, we're able to ensure that the messages are not only generated for all 35 rules, but they're generated in much more like equal proportions. And then these generated messages, once again, were also tailored to kind of like the linguistic characteristics of the messages that we observed from MomConnect. So after we created the data set, the next step was to find a model to train, right? So there are a lot of open source options nowadays for language models. I decided to leave out some of the more nuanced technical details. I'm more than happy to take any questions related to them. But that can get as technical and low level as one wants, right? And so I try to keep this talk a little bit high level. But in terms of like open source options, there's plenty nowadays for language models, right? And it can be difficult to select the best model, and oftentimes it's dependent on the task and the deployment requirements at hand. And so for us, we wanted a cost-effective solution, and we were targeting a specific task, trying to classify messages as either urgent or not urgent. However, we also wanted the model to provide its responses in a structured JSON format for easy post-processing and message sending via other APIs. And finally, we wanted the model to provide an explanation as to why it chose to classify a message as related to a certain urgency rule. So in order to do all of this, one needs a model, a language model that is capable of following and understanding instructions, and also has some capability to do general reasoning. And so because we had a partnership with Google.org, we decided upon the Gemma 2 model family, although there are certainly several other good options out there. And in particular, we chose the Gemma 2 instruction following models for fine-tuning. So these are models that are particularly well suited for a variety of text generation tasks, including question answering and general reasoning. And in addition, the Gemma team have also pre-trained their models to be safe and responsible, which was a plus for us. So after we selected the model, the next step is to essentially create the inputs and outputs, right? The like the samples for model training. And so the input to our model is one of the synthetically generated user message, and then the list of 35 urgency rules. And given those inputs, the model is trained to produce this structured JSON output shown here. And so you can see that there are three keys in this JSON output. The first is the best matching rule. So this is the urgency rule that best aligns with the user message. The next is the probability. So here we ask the language model to output essentially a confidence, and which is related to whether any part of the user message aligns with the selected urgency rule. The reason, the last key here is the reason, and this is the explanation provided by the language model as to why I chose the urgency rule and the probability. All right, so this constitutes the input and output pairs for the training set. During inference, the model will be given a user message, and then an admin can specify a list of urgency rules that they care about, and then the model would output the JSON format that you see here. So model training is another very complex subject. Oftentimes, if you've ever done this before, it's almost like it's more art than science in some ways. I purposely did not go into a lot of the technical details on the slide, but once again, more than happy to discuss it. So here are some of the main hyperparameter considerations that we played around for model training. The exact values we used are given in the appendix for those that are interested. right? So we actually tested out both the Gemma 2 billion and the 2 billion instruction tuned variant. So the difference between these two is that the 2 billion is just a language model. It just does next token generation. Is not specifically trained to follow instructions, right? But we were curious if we started out with that kind of model, how well we can get it to not only understand our domain but also follow instructions. Training these models are expensive to say the least. You need specialized hardwares. And so typically, once you get to above 1 billion parameters, you're doing quantized training. And so we played around with 4-bit and 8-bit quantization. And the trade-off there is you lose some accuracy and some capability of the model the more you quantize, because you're essentially losing information. We use parameter efficient tuning or LoRa, low rank adaptation. And then the usual hyperparameters like training batch size, gradient accumulation steps, and warm-up ratio. Right. So this is a rather large matrix of hyperparameters that one can optimize over. And by no means do we actually do all the possibilities here. Okay. So we train our model, and then we tested our model. And so this slide shows the main results. So we benchmarked our fine-tuned model against the GPT family of models from OpenAI. And all models are presented with the same instruction format and inputs and asked to produce the same JSON output. And these models are evaluated on a held out test set of 3,000 messages. So since most real user messages are non-urgent, there exists an imbalance in the test set. So thus we report both accuracy and area under the curve. As a baseline, we also show results from the base Gemma 2 billion parameter instruction model without any fine tuning. So just out of the box, zero shot performance. And for accuracy, we extract the value for the best matching rule key in the JSON output and compare against the ground truth label. The ground truth label here is just yes, no, corresponding to urgent or not urgent. And for area under the curve, we use the value for the probability key in the JSON output as a proxy for the model's confidence that the message is either urgent or non-urgent. Right. So you can see here that we are between GPT 3.5 Turbo and GPT 4o Mini for performance, which is pretty good for a 2 billion parameter model trained on 12,000 data samples. Right, we match 3.5 Turbo in terms of AUC, and we perform better in terms of accuracy. Okay, so some of the takeaways. Training a multi-billion parameter model comes with a lot of challenges, right? So data curation is cheap. We spent about $50 total, including experimentation with different curation procedures, but it's difficult to get right. There's a lot of mistakes that can happen when you're trying to set up your data pipeline. It's definitely an iterative process. And it kind of just boils down to how much time do you have to keep iterating, whether it's the prompt for the large language model that's generating your synthetic data set, right? Or and also just comes down to one's own experience. Like how many times have you done this before, so that you can avoid some of the pitfalls from the last time that you did this, right? And there's also just things that you cannot account for because you're in a new domain where you're generating data set for a new task. Right. So data curation, cheap and fast, but it's like cheap and fast to generate the data, but it's hard to get right. Okay. Model training is kind of almost the opposite. Model training is expensive because of the hardware, right? And the cost depends on the number of GPUs you want to use versus the budget that you have. Training is typically slow. It's for a 2 billion parameter model. We have about, it took us about 36 to 48 GPU hours. It's tedious to optimize. It's easy to waste resources if you're not careful. The good news these days is that, we have libraries like Hugging Face where they have like plenty of examples of how to set up your training code. One thing we did notice in this kind of supervised fine tuning stage is that we saw better performance when we trained the model to output the reason first, followed by the confidence, and then the best matching urgency rule in that order, right? Rather than, for example, having it output the rule first, then the probability, then the reason. And we believe this is similar to the chain of thought process where one forces the model to reason about its final answer before providing the final answer itself. Okay, so teaching a large language model to reason effectively and follow instructions requires a large amount of diverse, high-quality training data. And our data curation process generated 13,000 examples in total, of which only 12,000 was used for training. Due to the relatively small training set, we saw overfitting after about 2.5 epochs. And so, although our 2 billion parameter model it kind of exceeds GPT-3.5 Turbo's performance, it still lags behind GPT-4o and GPT-4o Mini. And we would like to see the Gemma 2 model match the performance of GPT-4o Mini. And so a larger, more diverse training set can help in this case. Our data curation process naturally biases towards messages that have a high probability of being urgent or non-urgent because our verification process used a language model to only accept those that actually match their labels, right? And so by default, it would have a high probability of matching their labels. But then after we trained our model and we manually inspected some of the incorrect predictions, we saw that some of the incorrect cases were ones where the user message is kind of ambiguous in terms of whether it constitutes urgent or non-urgent. And so these are instances where a judgment call is typically made on the fly by a human operator. And for these cases, we can actually teach the model to prefer one output versus another using training techniques such as direct preference optimization, DPO. But our first round data set lacked sufficient diversity for DPO, right? So we would need to construct pairs of synthetic messages with high, low confidence for a given rule so that we can try an advanced training techniques such as preference fine tuning. And then finally, a larger supervised fine-tuning data set coupled with a preference data set will allow us to experiment with the Gemma 2 9 billion parameter instruction model. Right? So there's evidence that larger size models exhibit these so-called emergent capabilities that allow them to reason more effectively over complex instructions. But then the challenge here is that hosting a 9 billion parameter model, especially on device for inference, is very challenging. And so the quantization and the knowledge distillation techniques that you would have to do is not trivial if you want to make the model still capable of following those instructions. Okay, thank you all for listening to my talk. I will take questions now if there are any.
Awesome. Thank you so much, Tony. We do have some questions, but also your coworker, Susan, has been helping you out in the chat and answering a lot of those too. Let's see. I'm going to throw them up on the screen and we'll see what we can get to if they have not been answered yet. Here's one.
Okay. Yeah, thank you, Susan. So, Susan, another data scientist at Insight, she's been with the project since the very beginning, and she's amazing. Okay, question. Have I noticed any bias in the Gemini model when generating synthetic data? Yeah, so diversity is a huge challenge when you're generating synthetic data sets, right? So there's been plenty of research papers out there that have shown that, it's not so much quantity anymore, right? Like you can do with like a factor of 10 less data if you aim for high quality, diverse data. In terms of bias, um, we didn't notice too much bias in terms of like messages that were heavily skewed one way or the other because we we took the extra step of attaching specific personas and instructions when generating the data, right? So we were already confining like uh, just how varied these messages could be, and they had to be related to a specific rule. So we didn't necessarily notice bias in that sense, but diversity was still an issue. So a lot of the messages they they tend to kind of how do I say this, like sound the same almost, right? So like the urgent messages always sounded urgent. It was always like please I need help or something like that, right? But in real life, like real messages, users can convey urgency in like subtle ways, right? And one of the things that we don't have access to is the history of a user's questions, right? And so when a user interfaces with mom connect the first time, their questions start off very generic, like hey, hi, I had this issue. But then over time it can kind of escalate to be more urgent, right? Or less urgent, right? And so we don't have that context. And that kind of prevents us from generating like a more diverse data set. I don't have a good answer for like how do you ensure that you have a high quality diverse data set. One of the ways that people kind of analyze data sets for instruction tune models, especially, is by kind of plotting like what is it, the verb noun plot, right? So it's like that pie chart, and it shows like the breakdown of like verbs and nouns used in your data set, and that's one way to do it, right? But that's like a very localized view of diversity. Good question though. How do you speed model training? Quantization. So anything above anything above 1 billion parameters, you almost have to apply quantization unless you just have a ridiculous budget or you have your own like workstation set up. So we found that going down to 8-bit was sufficiently fast for us without sacrificing too much model performance. 4-bit, the model started to perform really bad. 2-bit was just like gibberish. And I think nowadays you even see like the 1-bit model training. I haven't played around with 1-bit. So quantization can definitely help, but I think the reality for now is that if you're operating with 2 billion or above models, you just need the GPUs, right? So it's a very interesting like cost benefit analysis, because you can say like, oh, I can save cost by just having like one GPU. I'll quantize my model down to one GPU and increase my gradient accumulation steps or model batch size so that it fits. But if that takes you 48 GPU hours, like it's not a linear scale, right? Like if you were able to get two A100s, but then that only takes you say like 18 GPU hours, or something even less, then you technically save cost and you get your results faster, right? Which will allow you to iterate through things faster. So it's not as simple as like saying more GPUs will help, or like less GPUs will help, right? So it's like that's where model training is more of an art than it is a science. Sometimes it also depends on the training that you're doing. So this kind of training is supervised fine tuning, right? So when you're doing preference optimization, or like something like reinforcement learning, there's the training is a bit more complex, and it requires like a lot more stops and starts in your training process, right? So we were lucky enough to not to have experienced too many like manual stops and restarts due to gradient explosion or things like that.
We are running really tight on time, so I'm going to stop the questions. There are a few more. What I'm going to suggest is everybody jump over to Discord, and there is a link for that on the reception page. And Tony, if you want to hop over there and continue to answer questions and engage with attendees, I think you're having a really awesome conversation. I hate to cut it off, but we do need to end the session. And so Discord is a great place to do that. There is a talk discussions channel that you guys can continue speaking about this.
Okay,
But
well, I will hop over there.
okay,
Uh,
awesome.
Thank you.
Thank you, Tony, so much for being part of PyData Global and for this awesome talk and all the incredible work that you're doing. And I hope everybody else continues to enjoy the sessions during the conference.
Cheers.